Alright, hello everyone, this is Mr. Crozier. I wanted to help you with these problems from today's assignment. This is book set 4.7. So first off, a little review. You had this in the homework from yesterday and you had to simplify that, and without a calculator, two things you could do. You could say that's 2 to the 7th and the square root of that, but that's not going to be very friendly. Or you could say this is the square root of 2, but you have 7 of those. And another way to think of that would be the square root of 2, and let's go ahead and write that out 7 times just so you see it. 1, 2, 3, 4, 5, 6, and 7. So all of these go together to make 2 and 2 and 2. So that's 8 roots of 2. So this can be simplified all the way down to 8 roots of 2. It'd be a lot simpler to work with this than this if you need it as an answer. Alright, two problems from your homework. 11 and 52 I want to help you with. First off, the difference here is this has a higher exponent than a lower exponent. This one here has a lower exponent than a higher exponent. That's going to change the way you do both these problems. So let's look at this first one. If most of the time we'd set this up as a substitution problem, and that'd be a good choice. And then this would be du is dx, and this is 12x. And then if I multiply this over here and divide this over here, I have du over 12 is equal to x dx, which looks fine. However, the problem over here is this is dx over x. So over here we have dx over x, and over here they're being multiplied together, and we're never going to fix that. There's never going to be a way to fix that x and put it at the bottom and keep this here. So this plan's not going to work. A better plan is going to be to split these up and say this is 6x over x minus 4 over x, and then you can treat it as two separate integrals. This one right here could just be the integral of 6x, and this one right here could be the integral of 4 over x. Just treat them as two separate things and put them together at the end. This one now can be a natural log, and this one can be just a regular power rule. Alright, so when the exponent's higher, you're going to have to split them up to do the work. Now when the exponent's higher down here, it's going to be okay to say u is equal to, let's do this whole bottom right here, that's negative x to the 4th plus 4x squared plus 1. I just said u is that whole denominator. Put this in the front. Du dx is equal to, what is that, negative 4x cubed plus 8x. And now what we're having is we're having a cubed here, and the dx is always here, which is always over 1. So it's going to work out, and I think I can make this look like that if I just factor out a negative 4. That makes that. Now this is looking exactly like that. Move this over. Du over negative 4 is equal to x cubed minus 2x and dx. And see how they're together now. This goes right with this because they're both in the numerator here. So now you have everything you need to do to substitute in there and do the math. And again, when you're changing this to the world of u down here, go ahead and change these coefficients, or these limits right here, put them through here. If I plug in 0 here, that's 1. If I plug in negative 1 there, that's a negative 1 plus 1 plus 1, and that's just 4. So use this without having to go back through all of this, and then just plug in everything here, see what you need, and you will have it set up. Alright, hope this helps with your homework today.